These are the science review slides. So remember to listen to the slides and how I pronounce the science vocabulary. And then when you study, it's very important to read out loud so you can hear yourself using the science vocabulary. So remember in class, we learned that to measure mass, we use grams. That's the unit of measurement, and an apparatus called a scale. So we filled out a table like the one you see here. We measured the mass of different objects such as a pen, a dry erase marker, and we talked about the states of matter that we had found in each one. For example, a pen contains both a solid and a liquid. We predicted the mass in grams, and then we measured the actual mass in grams of each object. So when we made our prediction, we said, I predict the mass of the blank is blank grams on the scale. After that, we measured weight using newtons and a force meter. So newtons are the unit of measurement for weight and force. And the apparatus we use is called a force meter, like the one pictured. So we made our predictions, and then we measured the actual weight in newtons. I predict the weight of the blank is blank newtons on the force meter. So here is vocabulary from the unit of force and motion. First we have mass. Mass is the amount of matter in an object. Matter is anything that has mass and takes up space. For example, liquids, solids, and gases. A gram is a unit used to measure, in other words, count mass. A kilogram is also a unit used to measure or count mass. There are 1,000 grams in a kilogram. Weight is the amount of attraction on an object caused by gravity, and we learned that gravity is a pull force. Newton is the unit used to measure force and weight. Exert is an action. It means to push or pull to create a force. So when we measured the mass and weight of different objects that contained liquids, solids, and or gases, what patterns did we notice? As the mass of an object increases, the weight of that same object increases or decreases. If you said increases, you are correct. Likewise, if the mass of an object decreases, the weight of that same object decreases. So if you add more air, which is a gas, that would be carbon dioxide, to a balloon, what happens to its mass and weight? Remember, weight depends on mass and the amount of gravity an object like a planet has. So you may do this experiment at home if you have a balloon and a scale. The procedure is here. It starts with measure the mass of a balloon, no added air. Use a clip to hold it down, but subtract the mass of the clip. Add 5 pumps of air, then plus 5 10 pumps of air, then plus 5 15 pumps, and then plus 5 20 pumps. Create a table and graph to show your results. If you add liquid wax to a balloon, what happens to its mass and weight? A. Mass increases but weight decreases. B. Both mass and weight increase. C. Weight increases but mass decreases. Or D. Both mass and weight decrease. If you said B, both mass and weight increase, you are correct. So remember, we made observations, we looked around the room, and we noticed that things, objects, tend to stay still. In other words, they tend not to move. Why? Remember, Mr. Jeremy opened the door and we talked about what force he used. We made predictions. What force did I use to open the door? I used a push force to open the door. Remember how to draw and label force diagrams? This is a basic force diagram showing you one force at work. So on the left side, in this picture, it shows Mr. Jeremy pushing the door to open it. And in the other picture on the right side, it shows Mr. Jeremy pulling the door to close it. So what's the difference between a push and a pull? Do you remember? So here is a force diagrams cheat sheet, as we called it, explaining the difference between a push and a pull, and also showing you the different directions that a push and pull can move an object. So a push or a pull can move an object up or down or to the right or to the left. So again, what's the difference? A push moves something away from the force. So if you look at the X, remember the red X stands for the position of force. So a push arrow points away from the X. A pull moves something toward the force. A pull arrow points at X, as you can see from the different examples. So again, these two pictures, a car is being moved, but on the left side, a man is pushing the car because he's trying to move it away from the position of the X. And in the other picture, the car is being pulled toward the position of the force, which is the truck. So the arrow is pointing to the X. That's why it's a pull force. What forces are at work here? Do you see a push or pull? So in class, we agreed that this force, which made the ball move, was a push because the ball is moving away from the man. The man is the person exerting the force of push. And so the ball moves. Are there other forces at work trying to move the ball or slow it down that you can think of? Which force is stronger, A or B, and how do you know? In class, we agreed that the push force of B was stronger because we can see that more work was done. What do we mean by more work? Well, we noticed that more of the pins, you see the white things, were moved from their original position by the ball. What is force? Force is a push or pull that tries to change the position or shape of an object. Work is the amount of energy transferred when a force makes an object move. So on the left side, we see less work because not a lot of pins were moved from their original position. And on the right side, we see more work because more pins were moved or pushed from their original position. What is energy? Energy is when something has energy, it can make things move and cause things to change. So it's that something that makes things move and cause things to change. What is position? Position is the place where someone is standing or sitting, the place where something is put. So when we looked around the room, things tend not to move, they tend to stay in their position. Okay, unless you're human and you have energy, then you're probably moving. What is direction? Direction is where something or someone is going. And oftentimes, it's when someone is changing their position. They go in a certain direction. It could be up, down, right, left, for example. In class, we talked about opposing forces. Opposing forces are two or more forces that are trying to move or slow down in different directions. So in the diagram, we see two push forces. The bigger arrow means a bigger, stronger, greater force. We also talked about balanced forces. Balanced forces means that each force does the same work. The forces push or pull the same. When forces are balanced, things stay in the same position. Unbalanced forces means one force does more work than the other. One force, a push or a pull, can move or slow down something more than the other by changing that person or object's position more. So remember our tug-of-war force diagram? This force diagram shows balanced forces. So when the teams stay in their original position, no one is pulling harder than the other team, the forces are balanced. However, when the pull force of Team 4 is greater and stronger because Team 4 was able to move Team 5 in Team's 4 direction and change Team 5's position more, the forces are unbalanced. So look at the bigger pull arrow for Team 4. In this diagram, the blue team is a stronger force, so the forces are unbalanced. The pull force of the blue team is greater and stronger because the blue team was able to move the red team in the blue team's direction and change the red team's position more. So when you study, you can ask yourself these questions out loud and also answer them out loud. Number 1, which kinds of forces moved the rope and group of people? The forces that moved the rope and group of people include, number 2, who or what exerted each force? Blank exerted a blank force, blank exerted a blank force. How do you know Team 4 exerted a stronger force? Team 4 exerted a stronger force because... Things to remember. A stronger force is one that does more work than the other. Work is the amount of energy transferred when an object moves. Forces either help move an object or slow it down. And one of those forces is gravity. Gravity is a force that exists between any two objects that have mass. In this case, the forces are between the apple and the Earth. Why is planet Earth's force of gravity greater than the apple's? Gravity from the Earth's mass pulls the mass of the apple down. The apple moves in the direction down of the ground, and the position of the apple is changed. So Earth has more gravity because it has more mass. Remember the backpack lift challenge? This diagram shows equal forces at work. So maybe when you held the backpack and you were able to hold it in the middle without moving it, the forces were equal, but when gravity gradually pulled the backpack down and your arm got tired, then gravity became the stronger force, and so it has the bigger arrow. So here are the questions again and ways you can answer when you study. What forces are at work in this picture? What do you see? Do you see more than one force at work? There are at least two forces at work in this picture. First, we have the wolves pulling the man, and then we have friction from the snow on the ground surface slowing the wolves down. That's a push force. Question: which ramp surface will slow down the ball more? Cardboard, towel, or bubble wrap? What is surface? Surface is the outside part or uppermost layer of something. It's the top part of something, how it feels. And that could be smooth, less friction, or rough, more friction. So we predicted which which surface would slow down the ball the most. We talked about, before we started our investigation, how we can make it fair, and we talked about factors. So a factor is something that can change the result of an investigation. Remember, only one factor is different in an investigation. The other factors are the same. For example, in a race, everything is the same except the people. Now, the shoe color might be different, but this is not a factor that affects who wins the race. We talked about how to make a ramp experiment investigation a fair one, which factors needed to be the same and which was the one variable that needed to be different. Here are some of the factors that we said needed to be the same. For example, we used the same ball, the same starting position for the ball, the height of the ramp, so how high the ramp was. We tried to release the ball with no wind and discuss the only different variable was the surface. That's the one thing we changed in the investigation because that's what the question is about. It says which ramp surface will slow down the ball more. We also discuss which apparatus to use to measure length and distance. So the distance the ball traveled down the ramp, we used a tape measure, and the picture of the tape measure disappeared. But I think you know what that looks like. If you don't remember what a tape measure looks like, please Google that. Oh, there it is. So this is our procedure, how to conduct the investigation. I won't read all of that. And then we recorded our results. And remember we said we measure length in this experiment in centimeters. So cm, you see distance or length in the table. Cm stands for centimeters. So here's our question again about shorter distance and longer distance. We did a ramp force diagram, and our diagram showed that the ball traveled the longest distance on the cardboard only. It traveled the shortest distance on the bubble wrap. So why did it travel? Why did it move a shorter distance on the bubble wrap? So why did the ball travel a shorter distance or length on the bubble wrap? Well, we concluded that the bubble wrap was bumpier, it was rougher, and it had more friction. So it's a surface that has more friction. What is friction? Friction is a force which tries to slow or stop things sliding past one another. And we also concluded that friction is a push force. So, picture on the left shows a surface with more friction. Notice the man is not sliding or moving fast. But the picture on the right, the floor, the surface, has less friction, and the man is moving fast or sliding. So when we did our conclusion, and answered the question, why did the ball travel slower and at a shorter distance on the bubble wrap, we used all of these important words in our conclusion, including ramp, surface, cardboard, bubble wrap, towel, gravity, pull, move, friction, smooth, rough, push, slow down, motion, faster, slower, shorter distance, longer distance, opposing forces, and balanced forces. Look at your conclusion in your notebook for more information. One of the important conclusions that we made is that from our results, we can conclude that as the friction of a surface increases, the speed of the object and the distance it travels decreases. So this is another experiment you could try at home. So instead of changing the surface of the ramp, you change the surface of the object traveling down the ramp. So the variable, the different factor, becomes the surface of the object moving, not the ramp itself. So how could you make this a fair test if you did it at home? So remember, every surface has friction. Some surfaces have more than others. Which surface has the most? Which surface has the least? Why in these pictures? So here are examples of surfaces with more friction and surfaces with less friction. Which hands have more friction? We said the hands in picture B, because those hands show a rough surface, and a rough surface has more friction. If you move the boat with the same force, on which surface would the boat move faster and farther, and why? We said the water in picture A, because the water is smooth and it is not rough. Less friction. Why is ball B better for basketball? Because ball B has more friction, it's bumpier, it's rougher, and so when you are shooting a basketball, the ball will not slip or move out of your hands. In A, this ball has a smoother surface because in volleyball you don't have to catch or shoot a ball, you hit the ball, so you don't need a lot of friction on the ball. So if you are driving, which tires are safer to use and why? The tires in picture A or the tires in picture B? What do you think? Here is a YouTube link and video you can watch. I want you to think, why is it best to play a sport like hockey on ice? On what other surfaces could you play hockey on? Watch the sport known as curling. Why are they brushing the ice? Look at the video on YouTube and you can think as to why they are brushing the ice. Why do they use this machine on the ice? You can watch the video on YouTube. Lubricate. Lubricate means to apply a substance like oil to parts to allow them to move or slide more easily. So in this picture, here's oil used to lubricate the back. So when you get a massage, why would you lubricate someone's back? Here's oil used to lubricate a bicycle chain. Why would you do that? So in some situations, we want to create more friction, and in other situations, we want to make less friction. Question: which parachute size takes the longest, slowest time to touch the ground? Small parachute, medium parachute, or large parachute? Prediction: I predict the size blank parachute will stay in the air the longest. So remember, we talked about the factors that needed to be the same and the one factor that needed to be different for this experiment to make it a fair investigation. And we recorded our results on this table. We used a timer as the apparatus to measure time in seconds. And we concluded that the parachute with the large surface area stayed in the air the longest because it had more surface area. What is surface area? Surface area is the size of the outside part of an object. So we concluded that the larger the surface area of an object, the more air resistance. As the surface area increases, the air resistance increases. As the surface area decreases, the air resistance decreases. So as mentioned in the previous slide, these are different conclusions about surface area and air resistance that we made during this investigation. Okay, and we know gravity was one of the forces or at work during this investigation. We didn't push the parachute, we just released it, and gravity pulled the parachute down like it pulls this apple down. What is air resistance? Air resistance is exerted from particles of gas. They push against things which are moving. The friction or push created by air or gas. So air resistance is a kind of friction, but it's not on the ground, it's in the air, like you see in the picture. Does this diagram show balanced or unbalanced forces? Does this diagram show balanced or unbalanced forces? Is the air resistance pushing the woman to the back, or is the woman able to push through the air resistance? So we talked about what moved the parachute when we did the experiment. We said it was gravity, and was there an opposing force? Yes, there was. That was the air resistance. And we showed that on our force diagram. This diagram shows balanced forces. What happens to the parachute if gravity and the air resistance are balanced? People in class said the parachute would just float, and stay in the same position. But did that happen? Did the parachute just float and stay in the same position when we did the investigation? Nope. Gravity was the stronger force and pulled the parachute down. Okay? And we observed and measured that the large surface area parachute stayed in the air the longest because it was able to trap the most air, which meant the most air resistance. But in every case, gravity was able to pull down the parachute, and so it was the stronger force. It just took a little more time with the large surface area, okay? Remember that gravity was the same. Gravity was not stronger for the large surface area. It was the air resistance that was stronger for the large surface area. Gravity was constant or the same every time we dropped the parachute. So this is the diagram explanation again. As gravity pulls down the parachute to the ground, the air resistance tries to push the parachute up. The air resistance, a type of friction, slows down the pull of gravity, but gravity is the stronger force because it pulls the parachute down to the ground. The air resistance cannot keep the parachute up. So these are the words we used when we wrote our parachute conclusion. From my results, I can conclude parachute surface area, small, medium, large, gravity, move, pull down, air resistance, push up, friction, slow down, stronger force, unbalanced forces, opposing forces, timer, measure, seconds. Look at your notebook for more information. So if you were to plan another investigation, what could be your factor? What could be a different factor other than size of parachute? This is a YouTube video you can watch. You can predict a feather or a brick, which one will fall to the ground faster if you drop them. And these are other extra slides that you can look at, but I will go over. And that is it for force and motion. I hope this is helpful for your study for the checkpoint in October. Thank you.